really thanks codebar for hosting this event. I'm really excited and happy to be here today because I'm going to be talking about one of my favorite things in technology, which is the Go programming language. My name is Ricardo Gerardi, and I work at Red Hat as a consultant. I work primarily with automation with Ansible and also with container-based solutions. That's part of what got me into Go. And I'm also the author of the Powerful Command Line Applications in Go book that we'll see a little bit later. When we talk about Go, and this presentation being an introduction to the language, I just wanted to highlight a few aspects of it. So Go is it's a relatively new language. It's been out there for about 10 years now, and it's a language that is a little bit different from other languages. And I like it because some of these differences make it very useful for what I do. So I'm not a software developer, at least it's not my primary job. I'm a consultant, and I've worked many years as a sysadmin. So throughout my career, I was always working with languages, writing command line tools to help me manage systems. And so I used different languages throughout the years. And a few years ago, I came in contact with Go. And part of the reason was also because of some of the container tools that I mentioned, right? So Docker and Podman and Kubernetes, OpenShift, all of those tools that are related to managing Linux containers, they are developed in Go. And that's how I got started. Go has some nice benefits. So Go is a very concise language. It doesn't have a ton of features like other languages have, but being concise doesn't mean it's not powerful. You can still do a lot. It's very expressive language, and it's very fun to work with. Go is statically typed and is also compiled. So it's not a dynamic language. So you have all of that reliability, but at the same time, it feels that you are programming with a dynamic language. There are some aspects of the language that makes it to feel that you're programming with a dynamic language, but you still have the protection, some of the guarantees that the compiler provides you. One other big benefit is that it doesn't have any runtime dependencies. So when you compile a Go program, you create a single binary that you can then ship to other systems and just run it. You don't need to install a runtime, a JVM, or a Python version. And you don't need libraries in the system. And this is really good for developing some of these tools, because we always had that situation where I developed a program in my machine and I try to execute on a different machine, and then the version of Python is different and things don't work properly, or there's no one of the libraries that we require, it's not installed, and we don't have permissions to run pip and so on. And Go has also some interesting features that are native, built-in into the language. One of them is built-in concurrency. So concurrency in Go is not an afterthought, and one of the things that I'm going to show here today is how you can incorporate concurrency in your programs. Go is multi-platform, is also cross-compile, so I can develop my programs in Linux and deploy them in, compile them for Windows or Mac OS, for example, and deploy them there. And I don't need Go in the target machine to run the applications. So what I want to do here today is, instead of going through slides and showing some of the code, I'll show the language by working through an example. So we'll get into the command line and we'll develop a command line together. All of these slides and all of the source code for this is in GitHub, and I will send you the link after. And everything is also included in this presentation. So the presentation itself has all of the source code, so you can check that out after the presentation as well. But I'll go directly to the command line, and let's start doing some code there, right? The application that we're going to develop is a small command line application to check cryptocurrency prices. So at the end, we're going to have a tool that we can check those prices for one or many cryptocurrencies. And if we still have time at the end, and anybody's interested in seeing that, we can also try to convert that application to a web server, to a web application. So let's get started. So for that, I'm going to use a API called Messari, and I will just copy the address for that API because I don't have it. And let's start coding. So a program in Go is packaged in, it's organized in packages. In Go, when you are creating a executable file, you always start in package main, like I have here, and you start in a function called main. That function takes no arguments, returns nothing, and that's the starting point of your application. In this case, let's create a variable. When I was talking about Go feeling like a programming in dynamic language, that's one of the things that I was mentioning. So even though Go is compiled and statically typed, you can still create variables using this colon equals operator, which will initialize and assign this value to the variable automatically, and Go will infer the type of this variable based on the type of data that you are assigning to it. So in this case, this variable URL will be a string, and you cannot change it later, but you see that I didn't have to define the variable and define it as a string and then assign a value to it. I can do it in one line, and the compiler will help us with that. So now that we have the URL, we're going to issue an HTTP GET request to that URL to get the data. In this case, this URL is hard-coding BTC, which is Bitcoin for the cryptocurrency that we're going to consult. In Go, functions can return more than one argument. In this case, I'm going to use the HTTP package and the GET function to issue a GET a request into this URL, and it's going to return two types, so two values here of different types. So one is the response for that call, and the other one is a potential error. So if something goes wrong with the call, the variable error will be populated, and we can we know that something went wrong. And in Go, it's typical to check errors right after you see them. So Go doesn't have other forms of checking errors, and what you do is usually right after you get a return of a function that may contain an error, you check if the error is nil, if it's different of nil, meaning that there is an error, and then in this case we'll just print the error to screen and exit the program with a return code of 1. So we know at this time that something went wrong, right? And we'll see the error message there. Right? And then, assuming that the if condition is not true, then we know that there's no error. Then we got something in the response value there. And what we have to do is read that response. So the response will contain a body. Actually, there's another thing I want to do. Another important aspect is that when you're using external packages in Go, you have to import them. So one thing that I did here is my editor has as a shortcut. When I save the application, it will run a tool from the Go tools, which is called Go import, that will check packages, external packages that I'm using, and will write the import statement for those packages. So in this case, I'm using 3 external packages: the font or format package to print things, the HTTP, and the OS package. And then what we can do now is we can read the body. So in this case, I just want to read the body using the IO copy function, and I will copy the entire body to the standard out. That's going to be just the start of our program. So in this case, the response contains a body. The response contains a body, and we're copying the body to the standard out, and that's it. And there's one last thing that we need to do. So when you're reading a body, and you can check that in the documentation, you need to close that after. In Go, the typical way to do that is not by closing it directly. You can as well, but you can also use the defer keyword to defer the execution of a function to the end of the current function. So in this case, we're going to defer closing the body to the end. So it doesn't matter what happens with this function. At the end of the function, the defer statement will execute all of the calls that were stacked. So we have an initial version of our application here. So let's run it. Another characteristic of Go is that compiling Go is so fast that in general you don't need to compile your application and then run the application. There's a shortcut for that. So you can run the command go run and pass your file, and Go will on the background compile and run that application for you. And because compiling times in Go are so fast, it's usually something that you can't see. And you see that it already compiled and executed, and we got back JSON here that contains data about the Bitcoin that we're trying to check. In this case, just formatting it with JQ to see what we're getting. In this case, we're not interested in getting all of this data. We're only interested in getting, let's say, the symbol for that, the name, and the price in USD for that cryptocurrency. So what we're going to do now is we're going to start improving our program. Just in the interest of time, I will not do everything here. I will just load another version that already contains a library that I created. So we're in another version, and in this version here, I already have a library that I call Crypto, and this library does something similar to what we're doing in our first version of the Hello Crypto world there. But instead of printing out the value, we're still checking. We're still getting the JSON from that URL, but the URL now is dynamic. Instead of hard coding BTC, I have these. I'm using the sprintf with a %s and a variable called symbol, which is an input for the function getCrypto. So the getCrypto function takes a symbol as a string and return a value of type crypto that we're going to talk in just a moment. And we're doing something very similar to what we're doing before, but in this case, instead of printing out, we're creating a value of type crypto, and we're using the JSON package to parse that JSON that we saw into that type. So we're going to get a new type here. And the type is a custom type. So in Go, you have the basic types like strings and integers and floats, but you also can define your own types. In this case, use structs to define custom types. And I created a type called crypto. And that type it contains fields that are trying to mimic what we see here in the JSON. And this is just to make it easier for the JSON parser to populate the data. You don't have to do it this way, but it's practical in this sense. So we see that we have a data, and underneath it we have symbol and name. There are strings, and then I have market data and price USD. And that's what we're trying to obtain. That's the only information that's going to be parsed. And also note that in Go, Go doesn't have the concept of public or private types or identifiers. In Go, you identify a type as exported, so a type that can be seen outside of this package, so it can be used in other packages, just by defining the first character of the identifier's name as a capital, an uppercase character. So if it's an uppercase, it means it's exported. I can reference and use this identifier outside of this package, and if it's lowercase, it means that it can only be seen inside this package. So consider like a private. And in Go, it's also a convention not to use snake case. It's a convention to use camel case. So in this case, I have variables like market data and price USD in camel case, but in the JSON, they are snake case. So to make the parser understand which ones they need to parse, you use something called struct tags like this. So in this case, I have JSON price USD. So that's what we expect that value to be in the JSON that we're going to be reading, price underline USD, and that's going to be mapped to price USD in this type here. So now that we have this library, what we're going to do is we're going to use it, right? And so let me open that first program that we're working on before, and let's use that library now instead of doing this manually. So what we're going to do is, and also because the library now accepts the symbol as an input, I don't want to hard code this symbol. So I will create another variable called symbol here, and I will get it from the list of arguments for the program. So in this case, it's going to be the second argument, so index number 1. What we're doing here when we use the os.args function, os.args, in this case slice, is this is a slice. The slice in Go is similar to a dynamic array in other languages. Go also have arrays, but they're not very common to use. In general, you use slices, which are dynamic. So in this case, we're saying, hey, get the second item of that slice, so index number 1, and assign it to variable symbol. And why the second one? Because for Go, the first argument is always the name of the program that we're executing, and starting from the second argument is all of the arguments that we passed. And now, instead of using this, I'm going to replace this with C and call the package that we created that we called named crypto, and use the function get crypto from that package, passing the symbol that we're going to get as an input. And that's going to create for us here a variable C of type crypto. We can still check for errors, see if everything is okay. We don't need to close the board anymore. And what we can do right now is, because we have a C, we can just print it. So now our new version of the program is importing that package that I created. Again, the Go imports tool does that for me to make it easier. Don't have to do it manually. And what we can do now is, if we execute this program again with go run main.go, and we need to pass a symbol that for a cryptocurrency that we want to check. In this case, for example, Bitcoin, it will, because I mistyped something here. Always like that. There you go. It's print a line, the function. Let's try again. And there you go. Now we have the value that we're printing is a Bitcoin. The symbol is BTC, and the price in dollars, which seems to be higher than yesterday. One thing that you notice that I'm only printing the value of C. I did not add any formatting functions here of any type. We're just printing that value. And Go knows what it has to print, because for this value, this value has a function with this signature. It's called string, that takes no arguments and return a string value. When any types have this function, this type is implementing an interface. In Go, interfaces are implemented implicitly. So just the mere fact that I created this function, or this method in this case, right, and attached this method to the crypto type, anytime that I try to print that type, Go will check this function, will run this function, and this function has the formatting that we need. So everybody who tries to print this type will print the same format. We'll get the same result. Perfect. So next step now is, okay, it's nice. We have a working program here. We take an argument and we check an URL, right, and we get the value of that cryptocurrency. But it would be nice if we could do that for more than one. So instead of just one, let's see if we can do it for more than one. Right? So what I'm going to do here, just to make it easier for the next step, I will create another function here that I'll call print crypto price. That will take again the symbol, which is a string, and returns no values. And I will copy all of that code to that function. So it's going to do the same thing, but now it's in a function. And then from here, we call the print crypto price. We pass the symbol, and we'll have the same thing. What we're going to do now is, so instead of getting just one symbol, let's change this to get more than one input. So I'll change the name of this variable to symbol, and instead of getting just the second argument, I'm gonna reslice this slice and say get all of the arguments from the second one, so from index 1 to the end, so to list all of them here. And what we're gonna do is run this in a for loop. In Go, you have the common for loops like for, similar to C and Java's for loops, but in Go you also have another one that makes it easier to iterate through slices. In this case, it's called the range operator. So what we do is we're going to ignore the first value that's going to return because we're not going to use it. And the second value, which is the actual value of the item, we're going to assign it to a variable called symbol. And we're going to use the range operator on the symbols slice. And now we're going to iterate through all of the values from that slice. For each one of the values, it will assign the value to symbol, and then we're going to use symbol in the print function, and we're going to print all of them. And we're discarding. So this operator here, the underline operator, means discard the first return. The first return is the index of that item because we're not using. I'm discarding because in Go, if you're not using a variable that you defined, it's a compile time error. So either you need to use it or you need to discard. In this case, I don't need it, so I'm just discarding. So let's test this version. Now again, it's very similar. It can still print one symbol in this case, but we can also now add more. So for example, if I want to print also the value for Ethereum, now we can loop through and we can potentially even print many others. So let's try with some others values here. So for example, this 5 here. Yeah, so Polaris, Bitcoin, Polkadot. Let's also use Litecoin and see what we get. Now we're running that in a loop, and we're consulting the API, and we're getting the values for all of those cryptocurrencies. So what we can do now is that you can notice that when we're executing this program, you can see each value being printed, right, one by one in sequence, right? We're doing them in sequence, and each one is taking its time, right? It's obviously still quick, but if we're talking about a program that's running multiple things like this, or if we're now checking many other values instead of just 6, it could take a lot longer to complete. So in this case, let's see if we can add some concurrency to the program to make it run a little bit faster. So what I'm going to do before I jump to the concurrency, let's measure the time to see how long it's taken and how long it's going to take after. So what I'm going to do is I'm going to create a time stamp here using the time package. So I'm just grabbing the current timestamp with now, and then after we finish executing the program, I'm going to print a new line, and after the new line, I'm going to print the total time that it took to run this application. Total time, and that's going to be using the time.sinks function that tells us how long or the elapsed time between previous time stamp. So we're passing the start timestamp to that function, and it's going to calculate how long it took. So now if we execute again this program, it will tell us how long it took. So it took about 1 second to grab the data for those 6 cryptocurrencies. Okay, so now let's try to make this faster by adding some concurrency to it, right? So in Go, as I mentioned, concurrency is a built-in into the language. It's not an afterthought. So it's relatively easy to work with concurrency in Go. To execute something, a function in the background or concurrently, you just need to add the keyword Go in front of a function call, and that will create a Go routine. A Go routine is like a thread, but it's lightweight, so it's cheaper than creating threads. So you can actually create many hundreds, if not thousands, of those, and they don't cost as much as a thread in other programming languages. So if we do this right now and we try to execute this program, so all of those function calls now will be executed in the background. But what's going to happen is, see that the program exited immediately, took 57 microseconds now to run, but nothing happened. And the reason for that is these things are running concurrently, but they're not being coordinated. So what we did here is we sent all of these function calls to the background, but we never came back to check them, which means that the main function, which is was also running in its own Go routine, continued to execute. It printed the empty line, it printed the time, and it ended. And when the main function ends, the program ends, and it then cleans up all of the other Go routines that were executing. So we didn't have the time to check their results. So we need some kind of coordination here. You could just add a sleep here in this function to let it wait for a few seconds, right? But that's obviously far from ideal because you don't know exactly how long it's going to take. So it's going to be either too short or too long, and it's not the ideal because the inputs can vary. So to coordinate the execution of Go routines in Go, you use channels. So a channel is like a pipe or a communication line. So you send something to a channel, and then another Go routine is ready to receive that. It reads from the channel, and then you can coordinate those executions. It's like two runners on a relay race, right? So one of the runners have the baton, and that runner is running. When that runner is ready to pass on the baton, the other runner has to be ready to receive the baton. If they're not coordinating, then they cannot complete that interaction, right? So let's create a channel in Go. But I'm just creating a variable that will be our channel, and you create channels using the make function, and you define the type of channel that you want with the keyword chan and what kind of data you want to transport in Go. Because channels are, again, built in the language, you can transport anything. You can transport any of the basic types, but you can also transport custom types. So in this case, I'm going to transport our crypto custom type. So our channel will be transporting cryptos. And now we have the channel, but we need to use. So what we're going to do to use it, in this function, we're doing two things. We're getting we're fetching the value and creating the crypto type there, and we're also printing. So what we're going to do is the activity here that takes time is actually fetching the crypto. In printing is really fast. So what we're going to do is we're going to break this function into two so we can coordinate them apart. So what I'm going to do is just going to copy this entire function here, change its name to fetch crypto, and we don't need to print. Now we need another input parameter here, which is going to be the channel. So the channel is going to be an input, and the channel of cryptos like we defined before. And at the end of the function, when we obtained the crypto value here and we start in C, we're going to pass that C into the channel. And we do this using this arrow-like operator. And see that the arrow-like is pointing towards the channel, which means that in this case, we're sending the C value to the channel. Now we have something that is sending to the channel. We're going to need something that reads from the channel as well. So we're going to change our print crypto price function here that's now only printing. It doesn't have to receive a symbol as input anymore because it doesn't use it. We're going to change that to receive a crypto type because that's what we're printing. And now to make this work, what we're going to do is right here where we're calling print, we're going to change it to call the fetch function. And we're going to pass the channel. And when this is done, we need to read from that channel, right? Because if we're trying to write to the channel and nobody's ready to read from the channel, this is just going to block and it's not going to do anything. So what we're going to do is we need to read from that channel. But we need to read from the channel as many times as the channel is going to send something, right? So in this case, we know that we're running a for loop using the symbols slice. So we know that this for loop is going to run as many times as we have symbols. And so we're going to need to read from the channel as many times as we have symbols. So what we're going to do is another loop here. We're going to use the range operator again on the symbols slice, but we're not going to grab any of the values because we're not going to use. We're just interested in running it that many times. We're not using the values. And for each time this loop runs, we're going to print the crypto price, but we're going to receive it from the channel. You see that we do the same. We do that by using the arrow operator again, but in this case, the arrow operator is pointing out of the channel, not into the channel, right? So it means that we're reading from the channel, and this channel returns a crypto, which is exactly the input for this function. And in this case, we have that coordination now. So at this point, if we run this same function again that previously took 1.1 seconds to run, everything is going to run. Oh, okay, so let me try one more time. And that seems to be something with the API. I've seen it a few times and need to check why. But you see that now this time we ran the function or the program again with the same value. You see that they almost printed immediately together, right? Because they were executing concurrently. And instead of 1 second to run all 6, they ran in around 500 milliseconds, which is half of the time. Obviously, in this case, it's not much time that we're gaining, but you get the idea, right? If instead of 6, we're checking the price for, I don't know, many dozens or hundreds of these, then it would make a difference. And if you are doing something using Go that will read potentially thousands of lines of code or from somewhere, this can really make a big difference there. So at this point in time, we have a working program that checks the crypto prices concurrently, right? There's one more thing that I wanted to do is to show you how we can do the cross compilation that I mentioned before. So in this case, we have our main program here to compile a program in Go. We build it using the Go build program, and we can output with a name. If I just do this, we're going to build a crypto program, and that crypto program is Linux executable. I'm running this on a Linux machine, so it's a Linux executable, and it's, as I mentioned, it's just an executable, right? So I can run it again, and it will do the same thing. But what we can do with Go is as easily we can cross-compile for other platforms. So in this case, what I'm doing is I'm passing the value here, cgo enabled 0, just to, we don't compile with any link to C libraries. I'm then defining a Go OS variable saying that the OS, target OS for this compiling is Darwin, which is the nickname for Mac OS, and the same command go build -o crypto. So now we're compiling the program again, but instead of compiling it for Linux, we're compiling it for Mac OS. And that's the only thing that we need to run this program now. So I can copy this program, for example, to my Mac machine, which may not be working at this time. Let's see. We build a different IP address. There you go. Yeah. And now I can SSH into that machine. And if I execute the program that we copy into temp crypto and we pass a symbol, the program just executes. So we compiled in Linux, we transferred to this machine, and it executed. So that's pretty much it. Okay. So I think there was a lot that we covered here, right? At this point in time, oh, there's one more thing. So as I mentioned, this will be all in the presentation in GitHub. And if you want to learn more about Go, Go has actually some good resources for you to learn. So you can go to tour.golang.org, where you can execute programs and learn into in an interactive kind of tutorial. You can also go to play.golang.org, where you can write your own programs and execute them on the web without having to install Go. And you can also then check some of the documentation and so on, right? And this presentation will be available, and the presentation and all of the source code will be available in this GitHub repository here. Yeah. After that, if you're interested, when you're ready to tackle some other challenges, you can take a look at my book, Powerful Command Line Applications in Go, where we develop similar types of applications. It's all example based. and you can get it this week with a 30% discount. So the book is actually still in beta, but it's 100% complete. It's just in the final stages of review, and the final version of the book will be out in probably beginning of August. At this time, this is my Twitter link. So if you want to continue the conversation, I'm usually available on Twitter. So let me open up for questions now, and we can continue to talk. Thank you. Yeah, okay, I'm checking the first message. So yeah, from the first example, it's you got the undefined, right? Yeah, so that's one of the things that I know that was quick that I tried to mention. So you do need to import, right, those packages. And what I was doing is that my editor does that for me. So when I run save in my editor, it runs a tool called Go Import, which you can also check. And Go Import will change your source code file to include the imports for all of those packages that may be missing. Yeah, and that's pretty much it. And all of those packages that I was using, they're all standard library. I was not using, except for the crypto package that I created, I was not using any external packages. They are all part of the standard library. That's one of the things about Go. The standard library is fairly complete, and it's really nice to work with. Yeah, somebody's asking about putting Go programs in a container. Yeah, fantastic question. That's actually one of the nice things about Go, because Go is as we just saw, right? We can compile into a single binary. It's easy to create a container with Go, right? You can just create a container from anything, even from the Scratch container, which has nothing in it, and you just copy your binary to that Scratch container, create a new image, and that's it. You can run your program. There's a caveat to that, right? So some Go programs may depend on some external libraries. For example, if you're using something that uses like HTTP request, it may require connection to DNS, and so it may depend on some other libraries. So not all the time the Scratch container works, but in cases that it works, then it's just the binary. So, but generally speaking, it tends to be easier to get Go programs into containers, because you don't need to install a lot of the dependencies there. You don't have to install Go. You don't have to install external libraries. It's usually just the Go program into the library, into the container. Okay. Another question here, what kind of console applications on Go I use in my daily work? Yeah, so I've developed many programs in Go to help me in managing systems. And for example, I have command line tools to parse logs, to do some data analysis, also to parse CSV files that I got from a monitoring system. I have Go tools that I wrote to monitor systems, to help check and monitor systems. So these are some of the examples of Go applications that I use. Perfect. And yeah, thanks. Yeah, there's my Twitter handle over there. I'm usually active on Twitter, so if you send me a message there, I will respond. Thanks, Marcelo. I do use, the question from Gran is if I do use anything special in Vim. I do. I use a plugin called Vim-Go, and that plugin uses another tool from the Go tools, which is called Go PLS, and that's the tool that facilitates some of that. It's the same tool that you use in other IDEs, so it makes Vim behave like an IDE. As a matter of fact, I wrote an article for the Pragmatic Bookshelf Medium last week, teaching how to install Go in Vim. So if you're interested, just Google that, and you'll probably get it there.
One question above related to Hugo. Have you ever used this website generator?
Oh yeah, I love it. I have, I think, at this point in time, I think I have 3 or 4 different websites for different reasons, and they all powered by Go Hugo. Yeah, so it's a fantastic tool. It's a static site generator written in Go, so it's really fast. I think that's one of the things that they they mentioned there, compared to some other generators, it can create your whole site in a few seconds. Mine are not that big, but when I run it, it takes less than a second, I think, to compile my entire website, and that's it. Yeah, I highly recommend GoHugo.
I just popped a link to it now in the chat. It's gohugo.io for anyone who wants to check that out.
Thank you. This was really fun. Thank you.